So we're here to solve this Pentominous puzzle by JinHoo Ahn. This is another in a series. I think I'd actually say JinHoo has been making of these puzzles with 8 clues, exactly 3 letter types, very beautiful symmetry, really elegant puzzles. And given this is the Saturday puzzle, my guess is this one is going to be particularly hard. I'm going to turn on color and line composite to just get started. As in a lot of these puzzles, some of the pentomino shapes are far easier than others to deal with, and X's on the edge are a Monday level clue and a Saturday level puzzle. So let's just make sure we don't miss what these mean right at the start. And in marking them in, we actually isolate both the upper right corner and lower right corner into sets of cells that will have a particularly hard count. So if we have like those 4 in a group and these 2 in a group, these are different groups. Blue's got to come in, form this U. Red's got to extend and form an L, and not this U as a consequence over there. So these are easy starting points. Similar scenarios play out for us in the lower right. If we have this group in blue and this group in red, in all scenarios, red has to take this cell. But in taking that cell, we see the blue is absolutely isolated to be a P, and red to be a U. And we have these shapes coming in. Now I guess I'll convert over to using lines. It'll be a little easier to see things, and particularly as we get into this stage of the puzzle, we're going to have some groups that keep extending. In this case, this Y coming out all the way to here would now touch a Y clue, which wouldn't be valid, so this has to come down. And in coming down, we should see a few limitations. First, if the Y took this cell here as a crook, it would have to at least come down and take one more, and in doing that it's isolating these bits. And so there's some edges we can draw around this Y as we're doing this that should also now tell you that we have an F for sure as that pentomino. Any group that took this cell would leave behind 1 if we came like this or like this. So get this F in the grid. That's going to help us some. We now have a stalling point that's going to be pretty tricky, I think, to work through, and maybe some things to consider about, like, do these Y's connect or not. But as a first step, one thing I find useful in this kind of puzzle is to work on W clues as it would contain within a 3x3 bounding box. What I mean by that is, however a W goes, it will always have a width of 3 and a height of 3, and so any time you're thinking about a pentomino shape, you can say, do I know the bounding box it goes in? And if I know the bounding box, and I know, for instance, exactly if this W are the corner, I know the other corner and the center are used. I don't know anything more than say these cells are there. But one thing to see is that if the yellow is the bounding box, W's isolating some cells in the lower left, this would be invalid. And so yellow, this column for sure is not part of the bounding box. A different thing to think about is this shape all the way to the right, where again the W's, these are for sure. We don't know things like this or like this, but in both cases we've isolated too much to this lower right. We only get 2 or 4 cells for that space. And so one deduction I'm seeing that may help us a bit is that the W for sure fits in a shape like this. And in doing that, I actually know 1 cell of that W more than I started with, which is the W does have to come straight out first. And in doing that, the W will take this cell or this cell as part of the shape. So I'll give you a sense of the 2 shapes that are there. One is this, and one is this. And I'm trying to not sort of draw those in different colors in the grid, because people are, on paper you wouldn't be marking those extra things. But this line segment for sure is part of the shape that's going to be being formed from the lower right, that if it didn't do this, if it came over here, we've now like made a cut in that's not possible for the W to be in this yellow 3x3 square. And we can do one more deduction like that by saying if this edge isn't used, that then if this is continuing, this cell is used and it can't take this one, and if it takes this one, it's now a W next to a W, we'd have another issue. And so another deduction is that this cell is taken, and in doing that we actually can mark some more edges in an interesting way. Hopefully you think it's interesting, but one is this line to the left of this can't form a Z because we've then isolated too much away from this W. We also can't take this line up above. And in doing that, we start to now form another pentominous shape that's going to come out. And we can ask ourselves, is it potentially part of this Y or not? And one thing that's going to be useful in thinking through this, I'm imagining, is going to be the general count of cells going through these spaces. And thinking, for instance, if this is part of the Y, a Y looks like so, it's going to force this U, but that's going to force this W and force a very tight region here that's not going to be the right shape for the grid. This has to keep extending left to do the right kinds of things. There's still a case where, some of these cells are push-pull, that based on these particular W we use, we're going to not have a lot of options. But I think something like this is a reasonable space to get through in the puzzle. I then switch to a different thing I do a lot in Pentominous, which is just try to count cells. And one thing I saw for sure is if this Y came straight across, if it didn't use this cell, and in doing that, it can't, now we've marked more information, the grid has to come for away. We've got a weird count of cells down in the bottom. We have 6, 11, 17, this is out to 21, 22, 23, potentially 24. I've got to be able to take one more cell to get to 25 to have a valid pentomino count, and I could take this cell. Actually, sorry, I'm at 23 still, aren't I? 6, 18. Yeah, I'm at 23 cells, and I have to take 2 more cells. So if I take this W, I get 1 more, and that's not going to work like this. And that count is impossible. There's not a divide into a total of 5 multiples. So, I think seeing how blue is going to force a divide of this grid, now every cell in red and below, like this is kind of the meaningful count, is a set of things. I have 24 cells marked, so I either take 1 more in red or I have to take away cells to get down to 20, and the only cell I can take away that's in the above group is this one. So this is a count-based way of saying that a divide where the Y goes straight to the left is going to be a tricky divide to be using in the grid, and so the Y has to come up. And in coming up, we now know those edges, but it's still the case that we could have a few options for the Y here. And one that looks more problematic is this one, and it looks problematic because I'm pinning this group, which now is pinning this, which has to come out here, and I have that going through. And so this is still a little bit of deduction that you'll have to do in your head to get all the way out to these results. But I think it's a fast enough observation how these lines cause issue that you can get through it without too much extra consideration. So we'll mark in this Y shape. We now have, I guess, the right situation to start thinking about this W on the far left, which also needs to be part of some bounding box. And its bounding boxes will somehow sort of move through this space. But a key thing to note is that we're going to have to still get a count of 25 that's valid. So let's color in a whole lot of cells that are not part of the W. All of these cells will not be part of the W. And I guess I'll color all the way up to this clue. We can take back some cells if we need to. Right now we have 6, 11, 23, 27 marked in the grid. And I either want to take 3 more in blue and not touch the white W. That's going to be a problem. These are like how I get 3 more and the W's got no shape to go. Or I've got to give up 2. How am I going to give up 2? Well, if I gave up this cell, the W would then be like in these 5, and I would still have the wrong count here. If I give up this cell, I then can also give up this cell, and now the W is like this shape, and I've left behind a valid count of 25 in that part of the grid. So using this as the W, I can put in this line and can put in some more shapes like so. Some things to note are that, for instance, we now are in a case where this W is making an impossible split on the left of the grid. So to be able to place pentominos in a valid way, we've got to do this. we have these two coming up and these two coming down, and if these two groups don't join as an I, then what's going to be left behind is a P and a Z, but the Z is next to another Z. So seeing that there are two ways this area splits, but one has the wrong Pentominous touching, we get this IPZWT look of the bottom side in blue, get this W placed. We now have one last space to work on, but I'm going to again start on this by using bounding boxes, and I want to find the exact bounding box around this W. For sure, this looks really bad to me, and it looks bad because once I put in these cells, I have a count of 6 right now, or 4 if these two cells are used, but I'm never going to get a pentomino that can go in the upper left without leaving a cell. So this option, which uses those cells, is not possible. And the option like this, that uses these 3 cells, this would be a corner cell of the W and can't go further out. So the bounding box of this W, just like the one below, is something we can uniquely specify at this stage, and I will use that extra cell. That's not a lot to see, but there are also, remember, 2 options around it, and one of the options around it is going to give another count issue. We have 4 plus 2, so we can't form a pentomino, while this one is very valid and has a few choices for it. So at this stage, we can not only know the bounding box, but actually the specific W. I'm going to mark that into the grid. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells. So this is going to be the edge of some pentomino shape. If this takes this, I form a V next to a V, so it's this NP pair instead. And I now have to finish this out. These 3 cells, if they dodged this group, would take a 4th, but then 5, 6, that's too many, so these are part of the same group. Those are part of the last group. We get a U with an F, and we finish this challenging puzzle. Really easy start on the right side with those X's, some of those same kinds of steps I think we even had in like the Tuesday Tricks puzzle and how it breaks apart into U's and L's in these spaces. But the counts around these regions, the bounding boxes around the W's, some of these steps were how I made my way through the puzzle. Not sure if the author intended anything else, particularly these central Y's, but at some stage the count of this grid and the ways the Y's, if they avoid each other, would cause a pretty bad division of the grid was looking to be a key constraint in the puzzle. I resolved it by thinking about these spaces currently now marked in blue as a critical count for that area of the grid. So hope you learned something at least through my solve. If you had other ways you got through this puzzle, feel free to leave those notes in the comments, and we'll see you all again soon.